Hi everyone, my name is Moyakwalifu. I am currently teaching mathematics and science, grade 12 learners, college student as well as varsity student. So now in this lesson I'm going to teach grade 12 learners mathematics. Without any waste of time, I'm going to teach polynomial equations because I realized that polynomial equations are the ones of topics that most of learners get difficulties on it. So I spent a lot of time to digest these things of polynomial equations because most of students or most of learners from schools or from high schools are requesting me to teach them polynomial schools because even some of teachers, they are struggling to teach this type of questions. So let us pay attention very attentively, because if you really want distinctions, this is way to go for. This is a right path. You are not here by the mistake, you are here by the good time. So here's the question, and the tricky part is the factor theorem. And before we are going anyway, let me tell you one thing about polynomial equations. On polynomial equations, we have two types of method that we can approach to deal with this type of equation. The first method is long division, and the second method is factor theorem method. But at the end, you have to give you the same thing. And I realized that especially long division is one of the most difficult method. That is why it is not exam purpose for the grade 12 learners, because when I was doing grade 12 there in 2016, that is where I realized that this is not an easy as I it's really want a critical person, you see. So here we are going to apply a factor theorem. Factor theorem method, because factor theorem method, even factor theorem method is one of the difficult, or even, but it's not that difficult. I don't know what is the difficult, but most of learners get lost during the process of solving this type of equation, ne? So let us get started. So we are requested to show that x plus 1 is a factor of f at x is equals to 2x cubed minus 2x squared minus 10x minus 6 by using factor theorem. By using factor theorem. Ne? All right. So the first thing that you need to do in order for you, or in order for us to be assured that x plus 1 is indeed the factor of f at x, ne? So we are going to equate x plus 1 is equals to 0. We know when we equate something, we equate to 0. So we are going to say x plus 1 is equal to 0. Why are we doing this? We are doing this to get the value of x only. So when we want to, in other way, we want to solve the value of x. So therefore we are going to left with x is equals to -1. Why -1? Because we transpose positive 1 to right hand side, and we know that wherever you take other number from other side to another side, it changes sign. So after we get in that x is equals to -1, we have to substitute this x is equals to -1 in our original equation. And why are we substituting this in our original equation? our main aim or our main focus is to get f at x is equals to 0, since when x plus 1 is a factor of f at x. So when we substitute x is equals to 1, we have to get 0. It is always like that. If you don't get 0, you have to know that value is not the factor of that equation, because if it's a factor, when we substitute that particular value, specific value, it has to give us 0. And why are we saying x plus 1 is a factor? Because we want us at the end, when we factorize this, to multiply this factor with that simplification that we get from this equation. Do you really get it? So the first thing I said, we have to substitute this to get the value of 0. If we don't get the value of 0, we have to forfeit this. This is not correct. But if we get the value of 0, that is 100% correct. Let me get my calculator on. Here's my calculator. As you can see, I've already punched it. We have 2x squared. In the place of x, I substitute -1. So we have 2, and then we have x. In the place of x, I substitute -1, and then we have cubed. Minus 2. In the place of x, I substitute negative. If you don't see, let me get it closer to us so that we can all see. Here it is. So I substitute -1, but it is all squared. Then -10x. In the place of x, I substitute -1. Then we left with -6. Then what is our answer? Our answer is 0. As you can see here, our answer is 0. Then therefore we are sure that f at x is equals to 0 only if x is equals to -1. That is where our f at x is equals to 0. Only if x is equals to -1. That is where we will get f at x is equals to 0. Then we are sure that x plus 1 is a factor of this equation of 2x cubed minus 2x squared minus 10x minus 6. We are sure about that. Then now let us apply factor theorem. And there's a tricky part here when you're applying a factor theorem. Even on grade 12 books, most of grade 12 books, they don't teach this properly. They don't digest it so that some other learners, they get to understand this really. So me, I am going to digest it step by step so that you get really understand this. And I swear, after watching this video, you will get distinction. You are not going to struggle with solving polynomial, even if you get a university. Once you met with polynomials equations, know that factor theorem is applicable, because mathematics is mathematics. Even when you do you can do law, you can do accounting, you can do pilot, you can do engineering, but math is math. It's the same. It can't change. So let us apply our factor theorem. And there's a protocol, or there's a simple steps that you need to follow. You understand? So let us apply the factor theorem. And what the factor theorem saying? The factor theorem saying we only solve the factor theorem based on our equations. We are not going to solve factor theorem out of not equation. We are going to solve factor theorem based on our equation. That simply means we are going to take only the coefficient. But we are taking the coefficient with their sign. This is, as we can see, is +2. This is, you can see, is -2. This is -10. This is -6. Then we take everything with its sign, only the coefficient. Then we have the first coefficient of the first term on our equation is it's positive 2. Then I write only 2 because I know the number without any sign is positive. So then the second term is negative, it's negative 2. I write that negative 2 with its sign. Then the third term is it's negative 10, it's negative 10, it's negative 10. And our last term is negative 6. And we know that polynomial is this equation whereby they has 4 terms. As we can see that we have 1, 2, 3, 4, and then we have what you call quadratic equations. Quadratic equations is an equation that take only 3 terms, but it start with squared. Notice this difference. Polynomial it start with cubed, and quadratic start with squared. Then if we don't, let me say we don't have this term here, then this is no more longer polynomial, it's quadratic. But now we are dealing with polynomial. Okay, I'm not there, I'm here on a factor theorem. Let us apply factor theorem. Then the first step that you need to apply, or that you need to follow, factor theorem say you take the first term as it is. You take not the first term, you take the coefficient. You take only the coefficient of the first term as it is. Then you write underneath of this 2. Then I'm going to have positive 2. I write this 2 as it is here. Then I have 2. But once I move to another step, that is where I'm going to subtract this 2 from this negative 2. Don't get confused. I'm saying I am going to subtract this 2 from this negative 2. That simply means I am going to have negative 2 because this is negative 2, and then I'm going to subtract this 2 from this. Then I'm going to subtract 2, then minus 2. Then this minus 2 is negative 4. Then the second term I have negative 4. Then the second term I am going to subtract again. Listen very carefully, guys. When you're applying factor theorem, you only subtracting values from our original equations. You only subtract our underneath values from our equations. So we have negative 4. We see where I get that negative 4. Then the second step again, I'm going to subtract this negative 4 from this negative 10. So most of learners get confused because of these signs. Other learners might say this is going to be a negative 10 minus 4, of which this is going to give you something wrong. It's going to give you negative 14, of which this is wrong. Because you didn't subtract here. You just take that negative 4 as it is. So you need to be very careful when subtracting. Check here when I'm subtracting. I'm going to say negative 10 minus, then I subtract minus into negative 4, because that 4 it has negative. Then this is going to be negative 10. Then positive negative multiplied by negative is going to be positive. Then I will be having positive 4. Then you see the difference between this number and this number. They are much way different. Then this is going to be minus 10 plus 4. Minus 10 plus 4 is the same as minus 6. Then our value here, this term, the second term, our last term, is going to be minus 6. Then let us go to our last term. I'm going to subtract the very same value from our last term. I'm going to say negative 6. This is negative 6. Then subtract into negative 6 again. Subtract into negative 6. then this is gonna be negative 6, then negative multiplied by negative 8 is positive, it's positive 6. Then this is cancelled base because they are equal with the same number but different with their sign. That is where they cancel each other. Is the same as 6 minus 6, then our answer is 0. Here our answer is 0. Then I am very quite sure that my factor theorem is indeed applicable, because our last term underneath of our equation, our number of equation is 0, and indeed factor theorem is saying the last term, the last value that you get from our original equation, it has to be 0. Always it has to be 0 in order for you to get quadratic. If you can see, these numbers are no more longer polynomial, are they quadratic, because this is the same as the first term, whereby ax is ax squared, because this is the coefficient. Remember that here we are dealing with coefficient, so this 2 is gonna be represent a in this case. So in this term we have a x squared, this we have b x, and in this we have c. Then we have quadratic equation, in the place of a we are going to substitute positive 2. In the place of b we are going to substitute negative 6. In the place of c we are going to substitute negative 6. Then let us go further to see what we get. Then don't forget that x plus 1 is a factor. Now we are proving, or we are checking, now we are making our method to be strong application. So we are proving that indeed these factors are the factors. These factors that we get here are the factors of this equation. When we multiply this equation with this factor of x plus 1, that simply means we are going to say x plus 1 all into bracket, then open the other bracket and say because this bracket, I'm going to write these terms in terms of quadratic equation. I'm going to take these numbers from here on my factor theorem. The first term, it says ax squared. That simply means I'm gonna having 2x squared. Then the second term is gonna be minus x, minus 4x, minus 4x. Then the last term is gonna be minus 6. Then we know the rules of what you called the rules of solving equations, the rules of factorizing, the rules of simplifying. The rules of solving, it says we are dealing with bracket first. Since when here we have two brackets, that simply means we are going to multiply everything on the first bracket with everything inside the bracket. So how are we going to do that? I'm going to multiply everything inside this bracket with x only. Then again I'm going to multiply everything inside the bracket with 1, and then add the like terms to see what I'm getting. But these values, when I multiply these values at the end, I have to get 2x cubed minus 2x squared minus 10x minus 6. That is where I will be sure of my solving. Then I will be saying x multiplied by 2x squared is gonna be 2x multiplied by x squared is gonna be cubed, because we know that when we multiply the same bases we only add their exponent. That is where we have 2x cubed. Then we are going to multiply the very same x with the second term. Then the second term is already negative, then it's positive x multiplied by negative 4x is gonna be 4x squared, because x multiplied by x is gonna be squared. That is where I get to 4x squared. Then again I multiply the very same x with the last term. The last term is negative 6, then it's gonna carry that x, therefore I'm gonna have minus 6x. Again I will be multiplying the second term on the first bracket with everything on the second bracket, therefore we'll be saying positive 1 multiplied by positive 1 multiplied by positive 2x squared is gonna be positive 2x squared. Then positive 1 multiplied by negative 4x is going to be negative 4x. Then positive 1 multiplied by negative 6 then is going to be negative 6. Then it's going to be negative 6. Let us add the like terms. Then we check everything that is like to other term. We check the term that is like to other term. Is there everything that is like to this term? This term is this cube, it has cubed. No, we don't have cubed in this equation. Then we bring down as it is. Then we have 2x cubed. Then is there everything that is like to 4x cubed? Yes, we have 2x cubed. Then we are subtracting or adding the coefficient first. Then we have negative 4, we have positive 2. Then it's the same as 4 minus 2. Then it's gonna be minus 2. It's gonna be minus 2x squared, because here we are dealing with a coefficient, because the variables are the same. Then we deal only with coefficient. Then is there anything that is same with negative 6x? Yes, we have 4x here, but their sign are both negative. Then we write that negative sign and then we add the terms. Then we have 6 plus 4 is gonna be 10x. Then it's gonna be 10x. Then we left with negative 6. We left with negative 6. Is this equation the same as this equation? Yes, we have 2x cubed minus 2x squared minus 10x minus 6x. Then what we have here, we have the same 2x cubed minus 2x squared minus 10x minus 6. Then I don't think you will have problem with this. Signing out. It's Fazo, and I would like to say thank you very much. Bye bye.